Welcome to Yijin Hardware. Today, we'll discuss whether 5-axis machining will replace 3-axis machining as the mainstream method in the future. Like and subscribe to our channel, and let's get started. First, let's understand what 5-axis machining is. In terms of movement, 5-axis machining involves 3 linear axes, X, Y, and Z, along with 2 rotational axes, either A and C axes or B and C axes. The A axis rotates around the X axis, the B axis rotates around the Y axis, and the C axis rotates around the Z axis. During machining, these 5 axes can move simultaneously, allowing for the machining of all surfaces except the bottom, effectively reducing machining time and improving precision. In comparison, 3-axis machining can only move along the X, Y, and Z linear axes. Additionally, in 3-axis machining, the cutting tool cannot change its direction, making it difficult to machine areas like undercuts or deep cavities. To machine other surfaces, reclamping is required, especially when dealing with complex parts, which can be time-consuming. When we look at the machining methods, 5-axis machining is generally divided into 2 types: fixed-axis machining and 5-axis simultaneous machining. Fixed-axis machining involves tilting the rotating axis to a specific angle for machining, and then tilting to the next angle for the next machining operation. The rotating axis remains stationary while the spindle moves, which is why this method is called fixed-axis machining. On the other hand, 5-axis simultaneous machining allows all axes to move at the same time. For example, workpieces with complex shapes, like impellers, must be machined using 5-axis simultaneous machining. Here's a structural part. Let's see how much time it would take to machine this part using a 3-axis setup. How would you approach it? Think about it for 3 seconds. You can see that this product has many inclined surfaces and deep enclosed cavities. If you were to use 3-axis machining, you'd need to create several fixtures, and machining the internal cavities could lead to tool chatter. However, with 5-axis machining, the process is greatly simplified. The roughing and finishing of the enclosed cavities can be achieved by tilting the tool to enter the cavity, significantly improving tool rigidity and preventing vibration. This demonstrates that using a 5-axis machine can save a lot of setup time and optimize the machining process. From these 2 points, 5-axis machining clearly outperforms 3-axis machining. Now, let's talk about the advantages of 5-axis machining. 1. Greater flexibility in machining, reducing time and cost. Take the structural part mentioned earlier as an example. Without 5-axis machining, you'd need to spend a lot of time and effort creating specialized fixtures for each inclined angle. With 5-axis machining, angles and directions can be freely controlled, significantly reducing costs. 2. Compared to 3-axis machining, 5-axis machining offers greater freedom and flexibility, making it easier to machine complex shapes and surfaces. For instance, when machining the corner radius of this L-shaped slider with 3-axis machining, you'd have to extend the length of the tool to ensure there's no interference between the tool and the holder. But with 5-axis machining, you can simply tilt the workpiece to a convenient angle, eliminating the need to worry about interference and allowing you to reduce the tool's overhang length, resulting in a smoother surface finish. However, due to its structure, 5-axis machining does have some drawbacks compared to 3-axis machining. First, programming is more difficult and it requires more expertise from the operator. To effectively use 5-axis machining, you need to learn advanced programming, simulation, and machining techniques. Additionally, 5-axis machines are more expensive than 3-axis machines. So, can 5-axis machining replace 3-axis machining? I don't think so, but it will certainly replace many 3-axis operations. That said, 3-axis machining has its own advantages. Ultimately, the choice depends on which method creates more economic value in the given context. The option that truly reduces costs and increases efficiency will be the one that prevails. Compared to traditional 3-axis machining, 5-axis machining offers higher precision and efficiency. It can complete more work in a single setup and reduces the need for reclamping and repositioning during the machining process, thereby increasing production efficiency. Finally, I'd like to ask you a question. If you had to choose between these 2 machining methods, which would you pick? Leave a comment below with your thoughts. Subscribe to our channel to easily learn CNC knowledge and make daily progress.